So we've seen that in our framework, households derive utility from the consumption of private goods. So these are produced by workers that are employed by the private sector, by households themselves, and from the consumption of public goods and services. These are goods and services that are produced by the public sector, so by workers employed by the government. Now we'll introduce our first sufficient statistics. So sufficient statistics that's going to show up in the formula for optimal government spending. That sufficient statistic is the elasticity of substitution between public and private consumption, because it's going to tell us how easy it is to substitute public and private consumption. So it's going to play a key role in designing optimal government spending and optimal stimulus package. So let's introduce and define that sufficient statistic. So this first sufficient statistic is the elasticity of substitution between public and private goods. Elasticity of substitution between public and private goods and public and private goods and services, and we denote it by epsilon. So how do we define it? So this is just a standard definition for an elasticity of substitution. It's defined as follows: 1 over epsilon is equal to minus the elasticity d log of the marginal rate of substitution between public and private consumption with respect to the ratio between public and private consumption. So this is standard definition for an elasticity of substitution. So it is the elasticity of, basically, it's the inverse of the elasticity of the marginal rate of substitution with respect to the ratio between public and private consumption. So what are the properties of our elasticity of substitution? So we know that the marginal rate of substitution between public and private consumption is decreasing in the ratio between public and private consumption, public and private goods. So d log MRS GC divided by d log G over C, that's going to be negative, but there is a minus. So we know that epsilon, the elasticity of substitution, will be strictly positive. Now, couple of cases that we can have. So we'll have 3 different cases. So we'll have the case in which epsilon, the elasticity of substitution is strictly less than 1. And so just in terms of language, so in a case like this, we say that public and private goods and services, we call them a gross complement. That's when the elasticity of substitution is less than 1. When the elasticity of substitution is just equal to 1, then we say that the public and private goods are independent. And then the last case, of course, is epsilon, the elasticity of substitution strictly greater than 1. Then this means that public and private goods are gross substitute when you have a high elasticity of substitution. Okay, so a couple of special cases that are good to know. So let's look at 3 special cases that will kind of help capture what this elasticity of substitution mean. So one special case is when the elasticity of substitution go to 0. So, you know, this is when there is no substitution here. So in that case, we say that public and private goods are perfect complement. So what does that mean? Well, when they're perfect complement, it means that for a certain amount of private consumption, a certain amount of private goods, you need a certain amount of public goods. But then beyond that, the public goods don't add anything at all. So there's a level that's required, and then you don't need anything at all. So what type of utility function gives you perfect complement? Well, that's what you obtain with a Leontief utility function. So when you have a Leontief utility function, u of Cg is equal to mean of C and G, then you get in a case like this you get perfect complement. So if private goods C are at some level, when you increase public goods, that's going to be very valued until G reaches C. So if we can think of it in terms of goods and services, you can just think of it in terms of labor. When the number of public workers reaches the number of private workers, then after that, any more public workers are totally useless because the utility function is the mean of C and G. So then you have perfect complementarity. You need a certain amount of the public workers, and then more than that is totally useless. Then another interesting is epsilon equal 1 when the two goods are independent. So we said this is when public and private goods are independent. What's an example of epsilon equal 1? Well, that's a classic example with Cobb-Douglas utility. So when you have U Cg is equal to C 1 minus gamma G gamma, and you have Cobb-Douglas utility. In a case like this, you get epsilon is equal to 1. Why do we say that they're independent? Well, you can see, if you take the log of the utility function, you get 1 minus gamma log C plus gamma log G. And so you can see that the marginal utilities on C and G, once you take logs, are completely independent. So, so there is no relationship in a case like this between C and G. They do not affect the marginal utility. So in fact, if you compute, right, so basically, you can see exactly once you take the logs that the two marginal utilities do not affect each other. So how much of one of the goods you have doesn't affect the value of the other good. So that's really that's a perfect middle ground. And then we have the third now extreme case, which is when epsilon goes to infinity. So epsilon goes to infinity, then we say that public and private goods, they are perfect substitute. And so what would be an example of perfect substitution? That's what you get with a linear utility function. So when U of C and G is equal to C plus G, for instance. So in a world like this, you can see that what matters is only the sum. What matters is only the sum of C and G. And so whether it's only C that you have or whether it's only G that you have, it doesn't matter. Whatever of the composition, only the sum matters. And so they substitute each other perfectly. So in a world like this, actually, it doesn't really matter whether the basket of goods is tilted toward one good or the other. The only thing that matters is the size of the basket. So this is what, with perfect substitution, that's what you get with a linear utility function. Okay, so these are also different cases. for marginal rate for elasticity of substitution. So the elasticity of substitution captures how the marginal rate of substitution, which is just the value of the public good in terms of private good, varies with the ratio between the two. And so epsilon goes to infinity. The marginal rate of substitution doesn't vary with the ratio. That's when you have perfect substitute. When epsilon is equal to 0, they vary infinity. That's when you have perfect complement, and then you have the case epsilon equal 1, like that corresponds to the Cobb-Douglas case. And so what we will see now down the line is that this epsilon here, our elasticity of substitution, that's going to be a key substitution statistics in our formula for optimal stimulus spending.